Welcome to the Drive School. Today we are in the classroom for the real Drive School. This is the classroom where we train our customers, our students. We have simulators for shaft generators, microgrid applications, energy storage, active front-end, DC to DC converters, and ship propulsion system. And all of this is possible to connect together. Today we are going to look further into the shaft generator. It's a regular frequency converter with a special software which in this case handle a permanent magnet motor. Typical usage is between a diesel engine, a generator which can be a synchronous machine or an asynchronous machine. On the grid side, the DC bus, which can be connected to the AC grid and even to energy storage. Typical installations are shaft generators. It could be a big diesel engine on a ship, which drives the propeller shaft and the main propulsion units. There could be a generator connected to the shaft, and this shaft generator can, with this application, be used bi-directionals. That means you can extract energy from the generator, but you could also add mechanically power to the shaft by using the generator as a motor. The two main advantages with the generator application is that it's bidirectional. You can then use your generator as a motor, diesel electric motor. The other one is that the big diesel engine can now use a wide range of RPMs and you still can extract energy to your 60 Hz ship grid. Typically these big diesel engines, they have a high fuel consumption and are not very efficient if you run them too fast. So typically when the power demand is quite low, if you didn't have to run at synchronous speed as before, then you wanted to rev down the diesel engine, run your propeller very slowly to reduce your fuel consumption. But then before you needed to run at synchronous speed, which is too high speed for this big diesel engine. With the generator application, you can now slow down the big diesel. You can save a lot of fuel, and still the generator application will be able to produce the electric energy, transfer it into 60 Hz for your ship grid. The ability to run the diesel engine at a lower RPM and save fuel costs means that the synchronous generator is run at a variable frequency and variable voltage. The generator application still produces a constant DC voltage for its consumers. We can look at the generator application in a simplified way. Say that when it works in PTO mode, it only aims to produce a constant DC voltage of your selection. It will then extract energy from a motor or a generator by braking on it and put it into the DC bus, aim for the constant DC voltage, and any consumers on the same bus system can extract current and put it into batteries, AC grids or whatever. The other mode is when we want to put power into the motor to drive a propeller or a shaft. Then the generator application works more or less like a regular frequency converter, like the marine application. Then somebody else needs to produce the DC voltage on the bus. Maybe it's an active front-end or a grid application, or it even could be a battery. Then the energy will flow from the DC bus and into the motor. The generator application can be utilized in different modes, depending on which direction the energy is supposed to flow. Typically for a shaft generator, you can run it in commissioning mode, power take in mode, power take out mode, boost mode, and also the active front-end mode. You need to tune it, and then you go for the commissioning mode. You are then tuning your generator or permanent magnet motor more or less like a motor control system. Power take-in mode means that you are taking power into the system and add it as mechanically power to the main propulsion shaft. Typically you can then clutch off the diesel engine, shut it down, and you can utilize electric power from more energy efficient smaller diesel generators and put it into the shaft just like a diesel electric propulsion system. Power take out mode means that we take mechanically power out of the shaft and put it into the ship electric system. The boosting mode means that you are using the power take-in mode together with the main diesel engines. Both of them add mechanically power to the propeller shaft. You basically run then the synchronous generator as a motor and in a torque control. It just adds torque to the shaft. Since energy can flow in both directions through the system, the generator application need to be supported by a DC bus system which also is bidirectional. Typically the generator application is connected to an active fountain or microgrid application which is connected to the ship AC grid. It can also be connected to an energy storage, typically a DC to DC converter and a battery. The generator application is based on closed loop motor control. This means that the motor or the generator need to be fitted with an encoder. This is a speed feedback to the drive. This is to ensure the most precise torque control, and also many of these machines are synchronous machines like permanent magnet motors. Then we also need to know the shaft position, and this is to determine the polar angle, the angle between the stator and the magnets. Open loop is not a good solution for this, as the precision and efficiency will be lost. So you need to fit an incremental encoder, typically 1024 pulse per round, and typically you could use a opt A5 input board in the drive.